we will make an exciting deep dive into a hardware-in-the-loop setup, or HIL setup, specifically designed for testing the control and protection systems of a digital substation using Typhoon HIL. We will be demonstrating an intricate setup of differential protection of a power transformer and an overcurrent protection system. The differential protection scheme uses a real Siemens differential protection relay with the overcurrent protection of feeders and bus bars implemented using the protection library components available in Typhoon HIL Control Center software. The relays receives measurement data from the high voltage and medium voltage sides of the power transformer, seamlessly facilitated by a HIL connected device. It's important to note that for this setup to work, the differential relay and the merging units must be in local operation and must fulfill specific conditions for controlling the circuit breakers. These units control the circuit breakers by sending goose messages to the HIL device, all of which we will show in more detail. Plus, we will show you what happens when a power transformer runs into a fault, and how the differential relay steps in to save the day. Alright, without further ado, let's dive right into it. First, let's take a closer look at the setup. It comprises the following components: a 6MU85 high voltage merging unit, a 6MU85 medium voltage merging unit, a 7UT85 transformer differential relay, Siemens RSG2488 network switch with GPS antenna that supports P2P, a Typhoon HIL 602 Plus device, a HIL Connect device, and a PC with Dixie 5 and Typhoon HIL Control Center software installed. Inside of Typhoon HIL Control Center, we can use the schematic editor program to access the model. Here we can see the grid simulator, a high voltage transmission line, a power transformer, medium voltage bus bars, and 2 feeders with loads. The overcurrent protection of feeders and the overcurrent protection of bus bars are also implemented in the model. The real 7UT85 differential protection relay receives measurement data from the high voltage and medium voltage side of the power transformer through the HIL Connect device. Now let's look at the simulation environment. Let's compile and run the model and open it in HIL SCADA. Here we can see a high voltage bay consisting of 2 bus bar disconnectors, a high voltage circuit breaker, and voltage and current measurements. A medium voltage bay consisting of 2 bus bars disconnectors, a medium voltage circuit breaker, and voltage and current measurements. Feeder bays 1 and 2 consisting of a circuit breaker and voltage and current measurements. There are also 3 locations where we can insert faults into the simulation: in the medium voltage side of the power transformer, in the medium voltage bus bars, and in one of the feeders. During the simulation, the HIL 602 Plus device injects currents and voltage to the analog inputs of the high and medium voltage merging units via the HIL Connect. The status of the circuit breakers is sent by goose communication via the network switch. The merging units transmit data streams composed of sampled values to the 7UT85 differential relay, utilizing optical ports and a network switch. Switching equipment, such as circuit breakers and disconnectors, can be controlled via the SCADA panel, the 6MU85 high voltage merging unit, the 6MU85 medium voltage merging unit, or the 7UT85 transformer differential relay. In order to be controlled by the 7UT85 differential relay, the device must be in local operation and the conditions for controlling the switching device must be fulfilled. The same applies to the 2 merging units. The 7UT85 differential relay and the 6M85 merging units control the circuit breakers by sending goose message to the HIL. In the event of a fault in the feeder overcurrent protection picks up, blocks the busbar overcurrent protection, and trips the feeder circuit breaker after 600 milliseconds. In the case of a busbar fault, the busbar overcurrent protection model picks up and trips the medium voltage circuit breaker after 200 milliseconds. In the case of a fault in the power transformer, The 7UT85 differential relay trips both the high voltage and the medium voltage circuit breaker after 100 milliseconds. And there we have it. In this video, we had a detailed look at a hardware-in-the-loop setup, constructed specifically for testing control and protection functions of a digital substation using Typhoon HIL real-time hardware and software. We demonstrated how the real differential protection relay interfaces with the high voltage and medium voltage side of the power transformer through the HIL Connect device, and how it communicates with the HIL device via Goose messages. We also looked at different fault scenarios and the consequent reactions, showcasing the role of the differential relay in the feeder and busbar overcurrent protections. In all, the HIL setup is a powerful tool for studying how control and protection systems react to different grid conditions. We hope this video has offered valuable insights into the world of hardware-in-the-loop testing. Thank you for watching.